So let's talk about processes in Linux. A process is simply a running program. We know that most of our processes are running in what's called the foreground. That is, when we do ls, this is a command that is actually running here in the foreground of the shell. But you can run programs in the background as well, and this comes in handy for certain situations. For instance, programs that can consume the shell normally when they're run in the foreground, such as xclock, will take control of the shell. We'll notice that I'm not actually able to do any commands here on the shell. That is, until I close xclock, at which point those commands are issued. But what if I really wanted to interact with the shell while I had xclock running? I can do that by setting xclock into the background. And we set processes into the background by ending the command line with an ampersand, which signals run this as a process in the background. So now xclock is back up. We can see that it doesn't appear that I have control of the shell, but if I push enter, I now have resumed command of the shell. Xclock is still actively running, and I can type in my commands here. So this is convenient for running processes that are going to take a while in the shell, and you would still like to have access to the shell. Now, all processes are kept track by the operating system, and we can take a glimpse into which processes are running through the command ps. If we type ps and hit enter, it will list all the commands, all the processes that are running from the current shell. We can see there are only two processes running in this current shell. That's bash and ps, which we ran at that time. This isn't particularly useful because often we want to know information about what commands are running on the computer that we did not launch from the shell. To do that, we can feed ps two flags, E and F. If we do ps EF, ps will print out a listing of all the processes currently running on the system. Now this is a long list, so it's usually wise to pipe it to a pager, such as less. So let's go ahead and do that. And here we can see the output of ps. It lists the ID of the user that ran the process. It gives the process ID for that process. This is an identification number for that process. It gives the parent's PID, so the process that spawned this process. And it also tells you the name of the process that's running. So we can scroll through here, and we see that even on a fairly idle system, there are a lot of processes running. There's a lot going on in the background in Linux. Now, where this comes in particularly useful is in working with runaway processes. So let's clear this. So let's talk about runaway processes. I have a program in this directory called cpurunner.py, and all it does is waste processor cycles. So if I execute it by doing /cpurunner.py, we'll notice that it starts spewing junk to the terminal. And it will continue to do this to near infinity. This is obviously something we don't want to happen. One of my options at this point is to hit Control-Z. Control-Z places a process into the background. It actually ceases the process. Suspends it, rather. So now this process, CPU runner, which was burning my CPU cycles, has been paused. If at some point I wish to resume it, I can do so by simply typing in FG, at which point the process will happily resume. Now, let's say I don't want this to continue. There's the panic button in Linux for such a case, and that is Control-C. By pushing Control-C, I will terminate the process with a kill signal. So let's do that now. We can see that the program received a keyboard interrupt, the Control-C, and that stopped the process. There's another way to control runaway processes on your system, and that's through a combination of PS to get the process ID and a command called kill. So let's see how to do that. Let's get CPU runner going again, and let's say this process is run away and Control-C is not working. We can open up a new terminal and get the process ID of that process. So let's PS-EF, and we notice that CPU runner here has a process ID of 12205. If we issue kill, the command kill 12205, and then push enter, we then kill that program. So let's go back to the original terminal here. We can see that my program was terminated, and we can verify this with another PS-EF, and we failed to see it here. Now, sometimes you don't know exactly where in the output of PS your program will be. We happen to be lucky here because our process was near the bottom of the list. But let's say you didn't know that. Well, there's another tool we can use called grep. Grep simply takes an expression, a string of some type, and filters out any lines that don't match that expression. So let's say I started Firefox here. Let's shrink this down. Suppose Firefox was on the loose, consuming massive amounts of memory and CPU. How could I stop it? Well, the answer is quite simple. First we'll do a PS-EF, which we know to use to list all the processes currently running on the computer. We'll pipe it to grep, and we'll grep for the word Firefox. If we do that, we'll get the process ID here. It also returns the grep of Firefox, but we know that this is the process that we're looking for here. So my process ID for Firefox is 12280. So now I can go ahead and kill Firefox with kill 12280. We notice that Firefox stops running. We can also confirm this with another grep for Firefox after piping out the output from PS-EF. We notice that it doesn't return the process. So this comes in very handy for process control. And it's something hopefully you won't have to use too much. Oops. But it is a possibility.